How many of you guys were here last week? Okay, great. A good amount of you. Do any of you guys remember some of the stuff that we went over?
Yeah.
So that we can recap.
Yeah, we watched the VEX videos and then we went over what's on the board about the purposes of the robots and what they were using.
Okay, great. Does anyone want to add on?
We also went over like design, like, the definition of design.
Mm-hmm. Anyone else? All right. Does anyone want to try to define design for me? Give me your best definition. Give me your own personal definition. Yes.
Blueprints that point out the purposes of like what an item or an object is supposed to do.
Mm-hmm. Great. Anyone else? All right. So basically, we've all gone over design, and we do have the slides for you if you guys want to go over it further. But one of the things that we're going to talk about today is how we're going to apply design to our engineering notebook. So basically, one of the things that we have to do when you're in a VEX team is not just like building, right? You also have to do other stuff such as your engineering notebook, which is something that you turn into the judges, which are also judged on, and it contains information such as like your team information. You'll log all of your progress from throughout the year, starting from planning, starting from meeting each other for the first time to designing your robot to building to coding, stuff like that. So that's basically what your engineering notebook will be on. So yes, can you guys see this? So some of the reasons why we make an engineering notebook for ourselves is not only to turn it in for the judges, but also to keep track of our own progress as well as some of your designs. So if you guys have like an idea, you can go back to your design notebook and realize that, oh, maybe we've already gone over something like this and like some of the reasons why we may not have chosen it. And then you can build off of that. You can also use it for like future reference. If you continue to do this for multiple years, you can go back and see like, here's some of the things that we did last year and how it helped towards our competition, and if we can use some things that we used last year towards the competition this year. It's also like really cool for memories. You can go through your documents when you're like 80 and you're like, oh, this is something that I did in high school. That's really cute. Anyways. I don't know. Some people want that. We're not judging you. Alright, so some of the things like I mentioned before, the things that you will be putting in your notebook are your team information. So you'll be putting individual biographies about your team members just to like introduce who's on the team and what they do, and some of your individual roles and how your own personality traits bring to the team and improve teamwork. So, and then you'll also do the progress, which is from day 1 to like D-Day, basically the competition. What are some of in a very light. You don't use those bad choice of words, but some of the what you went through, what decisions you made, what you guys put into the robot basically throughout the entire year leading up to the competition, and then you'll put like robot design. So you'll have like, as he said, your blueprints, some of your parts, a full design of your robot and like breakdowns of some of the different parts of it, as well as like your code. And then one of a major aspect of design of the engineering notebook that people will look at, the judges will look at, will be your organization. So like a table of contents, and you'll have like page numbers and stuff like that. You can also, as I mentioned before, you can also be awarded based on your engineering notebook. So there's something called a design award. I don't think every competition does it, but most do, and I believe states does it too. So you can actually use this design award. The design awards can actually put a spot in Worlds, which is really cool. So what they judge is on your basically the layout of your notebook, how like what is the word for it?
Organized?
Yeah, well, yeah, of course, organization, but like
thorough.
Yeah, how thorough. Thank you, Sai.
Of course.
How thorough and organized your notebook is, and so basically, like, did you put like what they recommend for you to put in the notebook? Is it there? They also, however, your design award is also based on an interview. So when they come around in competitions, they'll come around to your table while you're waiting, and they'll ask you interview questions like, oh, like, what did you as an individual bring to this team? Or what were some of the decisions that you made in this team? Why did you use this instead of this? And they'll look to see how well you guys as a team understand your robot, if that makes sense. So we have an example. This is one of the engineering notebooks that we used last year. So this is...
Go back to the...
Oh, I got it. Oh, no. But basically, it was just going to show you one of the engineering notebooks from last year that Team 1251X used for theirs and how they organized and what they added to their notebooks. So we can move on to that, yeah.
So, now, we have a very fun activity we're going to do today, and you might have heard of it before. We're going to build spaghetti towers. Basically, all this is aiming to get you guys to do is to start working together and actually designing something for yourself. So you're going to create the best and tallest spaghetti tower you possibly can with a team of 4 or 5, depending on how many people. We're going to give you 20 pieces of spaghetti, a foot of tape, a 3 feet of string, and 30 marshmallows, and you're going to just build the tallest you can. The person with the tallest tower and the one that can stand up the longest is going to win a super secret prize. Who knows what that is? I don't know.
You get to eat the box of spaghetti.
And also, if you guys don't make some sort of blueprint, some sort of design that we can see, then there is no prize. You don't get it, regardless of if you have the tallest tower or not. Alright, so go ahead and break up into groups of about 5.
You guys can go ahead and make your blueprints on the whiteboard table. We do have markers.
Hey, if you guys aren't too busy, do you mind explaining what your process is?
I have no idea.
Okay, so we're gonna have like boxes that look like this.
Sure.
We're gonna put a line through each of the sides. We're gonna build up, and then we're gonna have this. It's like a pyramid at the top, and from there we're just gonna have a long stick of the spaghetti.
I like the idea, but the thing with those type of things is they limit height when you create so much for a base. So just a suggestion to keep in mind.
This was gonna be the flat at the base, so like this would be like able to support the rest of the build where we're gonna build up with this, and then we're gonna try to see how far we can.
Sounds good. Thank you for telling me. You guys mind explaining your design to me?
Okay, yeah, sure.
We have a tripod design, 3 pieces of tape holding down the individual side struts to the ground, and there will be a marshmallow foundation, and then we'll have spaghetti that slopes up, and at each level it starts to point inward, and so the space in the triangle gets smaller.
Nice. Do you want to pick up your materials?
It's like a pyramid.
Right, I get it.
Alright.
That's cool. So you're having a triangle, then a
Yeah,
pyramid,
then a
and
smaller triangle, and then a small. It looks curved because I don't know how to draw it.
But that's a really cool design. Thanks. Hey, if you guys aren't too busy, do you mind explaining your design?
So basically, our design is we are using a triangular base, basically like this. And then that's connected to the center, which goes up. And it's pretty basic, but I believe that the way that we can maximize structural integrity is by extending it further upward past. So if it goes like that, then we also have it going like that as well, and then that should secure it up at a higher point.
Are you planning on using the string to support so it's like, you know, too top heavy at one side?
We'll use it, but that's not.
If it's too top heavy on one side, then we'll just like put marshmallows on the other side. So it'll be balanced.
Sounds good. Thank you for your time.
We should still have structural integrity.
Okay.
No, we can't tape up the sides and then tape it to the table.
Nice job. Using your resources.
What happened?
Sorry, Eric.
As you can tell, we're doing really good.
Wow, look at that.
And then we should do one on top, and that'll be it, right? Go ahead, do your stuff. We have 3 minutes. Okay, only 2 minutes. Cut the string, cut the string. Cut the string.
It's not going to use the excess on the bottom. Oh, that was actually Of course, no. I would just try to plug the channel.
Because we are measuring on height, our group in the back did win.
Yeah!
However, all of your guys' designs and effort was commendable. It was
Yes.
So thank you guys so much. And the group in the back and Sarah, we're gonna take a picture real quick.
Yeah. Let's go.
Hey, we're gonna. Can you guys take a picture of yourself real quick?
Oh, yes, yes.